Normally when I go portable, I use 20 metres of wire as an end fed. However, there's different ways to configure the wire. On 20 metres for instance, it can be made a full wave loop. Today, I'll try it as a delta loop, optimised for low angle radiation. Having a look at the loop, the formula says you need a full wavelength plus 5%. On 20 metres, that works out to be a perimeter of around 21.6 metres, or 7.2 metres a side. I'm feeding the antenna just above the corner. It actually needs to be 1/4 wavelength below the top apex. That's 5.3 metres, and the bottom bit about 1.9 metres. Feeding loops at the bottom gives horizontal polarisation, whereas feeding them at the side gives you vertical polarisation. If you're near a good ground, such as salt water, and you want to work low angle DX, then vertical is the best way to feed it. Full wavelength loops have an impedance of around 100 to 120 ohms. To match that down to 50 ohms to your transceiver, you could use a 1/4 wavelength piece of 75 ohm coax. I'll be a bit different. I'll instead use a 1-to-1 balun at the antenna feed point and then use an antenna coupler to bring the impedance down. The ARRL Antenna Handbook has some information on delta loops. However, I found ON4UN's low band DXing the best reference on them. As for the support pole, if you're using an 8 or 9 metre skrid pole, you don't need to extend it to its full length. With the help of Pythagoras, you can work out that it needs to be around 6.2 metres. The line you see here is the 21.6 metre of wire, divided into various points where you've got your corners of your triangle or your feed point. When you're building wire antennas, you need things to support the wire. I use pieces of kitchen chopping board. As you can see here, there are holes drilled in them. At the feed point of the loop is this balun, 1-to-1. It's just a few turns of wire, bifilar round on a T50 43 ferrite toroid. I'm being a bit slack because I'm using figure 8 cable for the section of the antenna between the balun and the antenna coupler. It's only a short length, so I should be able to get away with it. You'll notice that unlike some piers, the railing is timber. That's particularly good for an antenna like this delta loop because there's less interaction between it and the wire element. The receiver sounded more alive than with other antennas, even accounting for the contest going on.
For this contest, the U.S. stations are going to want your power, so your exchange would be 59005. QRZ kilowatt 0, Tango Victor, contest. Okay, Victor Kilo 3, Yankee Echo, 59 New Hampshire. Whiskey 0, Alpha India Hotel, contest.
VK3 Yankee Echo.
Victor Kilowatt 3, Yankee Echo, 59 Whiskey India. VK3 Yankee what?
Yankee Echo, Yankee Echo.
Okay, VK3 Yankee Echo, 59 Pennsylvania. Okay, alright, well thanks a lot for calling in. QRZ, Kilo 3, Lima Radio. CQ contest, Whiskey Echo, 3 Charlie. Signal for 5 watts, 59 Pennsylvania, Papa Alpha, QSM. CQ contest, K1CO, kilowatt 1, Tango Ocean. Roger, VK3 Yankee Echo, 59 Florida.
Roger, roger. You are 5'9" and running 5 watts, 5 watts QRP, over.
Wow, 5 watts, very good. Thank you for the call. 73. VK3 Yankee Echo, 59 North Carolina.
Roger, roger. You are 5'9", running 5 watts, 5 watts QRP, over.
Oh, great, for 5 watts. Thank you. QRZ from November 40. Zulu Charlie. Roger. You've got a good signal, but that VK6 Alpha Papa was really, really weak. I've worked a couple other mobiles and the rest, but you know, it kind of varies. Good signal for 5 watts. VK3YE, Whiskey 6 Whiskey Bravo. Okay, Yankee Ecuador, Victor Kilo 3, Yankee Ecuador. You're 5'9" Massachusetts.
Roger, roger. You are 5'9" and running 5 watts. 5 watts QRP. Over.
Okay, great job for 5 watts. And 72, thanks for the call. Thanks. No QRP. Impossible QRP. Right, it was great to work in QRP. Impossible 5 watts.
I am QRP 5 watts. 73.